G'day guys, Mr. Bennett here. Today I'm going to just be looking at reviewing field lines. Now whether you're doing electric fields or magnetic fields, the same concept sort of works here. Field lines always go from positive to negative. They always go from north to south. Alright, so the main thing is that you can just draw a uniform field. So I've showed you in a previous video how to do for parallel plates. But if we've got a point charge, let's say it's a positive point charge, well our particular field lines will go out in that direction there. Alright, so you just draw a nice symmetrical diagram, keeping in mind this is actually supposed to be 3D. We can't draw it 3D, so we'll just draw it 2D. Alright, so that's that sort of concept. If we've got a negative and a positive, right, so obviously the field lines then sort of follow a symmetrical shape, going from positive to negative. So don't draw too many, it's about getting the detail right, I think, with this. Okay, that goes out there, that goes out there. Got a shape there. Right, so they're all going in, and then we make it symmetrical. Okay, so it's about symmetrical. You know, don't do too many field lines, and they're all going away. Alright, so that's that particular example. The other thing you can have is a hollow conductor. Alright, so when we're talking about a hollow conductor, we're talking about something like a Faraday cage. So quite often you'll see something like that, and I'll say it's a hollow conductor, a big sphere. So basically what you're going to have there is you're going to have no charge inside the conductor. But if it's got a negative charge, you've got a negative charge on the surface there. Okay, so there won't be any field lines inside the conductor, but there'll be field lines going in towards this thing. And again, you know, you need to do them as being symmetrical. That's the secret. So just work your way around being symmetrical with it. Don't have to do too many field lines, but you get the idea with that. The other thing we know about field lines is they are more concentrated at points. Okay, and we'll talk about that when we look at the photocopier and the corona Y. Okay, so if you're looking at something like this, okay, your field lines have to be more focused at, you know, that particular thing there. Won't worry about the direction. And then out here, they're going to be less, you know, again, trying to make them fairly symmetrical, but you get the idea that I'm concentrating all the field lines around that sort of area there. It's about then getting the direction, depending if it's going being a positive or negative. Alright, so make sure you know how to draw these field lines, and like I said before, it's fairly similar when we do things like the magnets as well. Alright, so pretty simple. Alright, just make sure you never let these field lines, the lines cross over. And obviously you have through out here, you have lines of equal potential, and they are basically distances that are equal from that particular field line, and they run at 90 degrees to these field lines. Alright, so you'd have equal potential lines going sort of through here and through there. Alright, so and then you'd have probably an equal potential line going down the middle there as well.